Alright, hey guys, so we're going to start off talking about polar coordinates and what do I mean by polar. Polar is something totally brand new, okay? And you'll see something that kind of looks like this, and it looks a little weird, and I'm actually not a huge fan of this picture right here, but you'll notice that it kind of looks maybe something like the unit circle, with all those sorts of lines, and you're given some coordinates here. Okay, and basically when we're given polar coordinates, we're given an angle, okay, and that's what's represented by the second part. So I'm going to go ahead and label that, and you can call it theta, okay. You're given your angle, and then you're given, you can kind of think about it as how many spaces you're walking, okay, and that sounds kind of weird, but hopefully in a second it'll make a little bit more sense. So we always think about, like, we always start in the middle. So I'm always starting in the middle. You can think about as the origin, but we don't have an x and a y axis, okay? And so polar coordinates are going to allow us to graph things a little bit differently, and they're going to allow us to graph things that are with kind of sine and cosine, and you'll see later on how we actually use polar coordinates to graph different sorts of, such as sine of theta, cosine of theta, etc. Alright, so first thing I'm going to do is I'm going to look at my angle. Okay, so 7 pi over 6. And so what I'm going to do is, since that's positive, I'm going to go over to 7 pi over 6. Now to help myself out a little bit, I'm going to go ahead and just label here. So, and that's why I said this is not, I'm not the biggest fan of this one because it's not, usually it'll give you kind of the actual lines on the unit circle, but actually you notice that it falls kind of, oops, that the lines actually kind of fall between there for the unit circle. So this would be like pi over 6, pi over 3, and I'm just going to do the first quadrant so that you get the idea. So 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, and 6, 6. Okay, so now we have something like that, and so then we know that 7 6 would be right down here, 7 pi over 6. Alright, so I'm going to start right here and I'm going to face this direction, okay, and then I'm going to walk 6 spaces. So what I mean by that is each line is one space. So 1, 2, 3, 4, 5, 6. And it should be kind of in the middle. I'm just bad at drawing. Okay, and I'm going to label that point A. Alright, I'm going to do the same thing for point B. Okay. But this time you notice that the angle is negative. Well, we know how to do that. I'm just going to go backwards 3 pi over 4. So think about, like, if I were over here at 0, I would go backwards 3 pi over 4, and you would end up on this line right here, which is, that would be 5 pi over 4. So this line right here is 5 pi over 4. Okay, because if you start at 0 and if the angle is a negative, you know that you're going to go backwards. And this says that I go 3 spaces. So 1, 2, 3. And I'm going to label that point B. So again, I'm just practicing plotting these points. Alright, the next one is C. So that one says 8 comma pi. So I'm going to face in the direction of pi, and I'm going to go forward 8 spaces. 1, 2, 3, 4, 5, 6, 7, 8. And that's going to be point C. Alright, the next one, and you'll notice I'm using the language like face in the direction of, and there's actually a reason why I'm doing it, and it's going to come up in right now in point D. So 5 pi over 3. So first let's find 5 pi over 3. Okay. So we have 7 6, 8 6 would be right here. So that down there would be 4 pi over 3. And then right here then would be 5 pi over 3. Okay, so right here then, I'm going to be facing this direction because that's where my angle is, right? 5 pi over 3. Okay, and you're always starting at the center, at the origin. However, this says -6. So I'm facing 5 pi over 3, but you can kind of think about it. I did this last year in classes, like we had chairs and I was walking backwards. But you can kind of think about it as I'm walking backwards 6 spaces. So 1, 2, 3, 4, 5, 6. So I'm still facing that 5 pi over 3 angle, but because it's negative, I had to go backwards from that angle. Okay. All right, let's do another one that's negative. So first I look at my angle, -11 pi over 6. So start at 0, okay, to get your angle. -11 pi over 6. Well, this is where my angle is going to be, at positive pi over 6. Okay, so that's the direction that I'm facing. Okay, so I'm facing pi over 6. I'm looking that way. But I have to, it says -5. So that means I take 5 steps backwards. So 1, 2, 3, 4, 5. So it should be on the same line as A, okay, but it should be in front of A or closer to the, we call it the pole, not the origin, but the pole is just this point in the middle. Okay, and last one is -2 pi over 3. So for -2 pi over 3, you can go backwards 2 pi over 3. Okay, so if I go backwards 2 pi over 3, that's going to end me up at 4 pi over 3. Okay, and so then I have to go -4. So I'm facing 4 pi over 3, and I need to walk backwards 4. So 1, 2, 3, 4. And that is point F. Okay, so that's plotting polar coordinates. Okay, and that's a big, big, big part of what this unit is, being able to identify those, etc. All right, so next we're going to talk about, we know that there's, we can go around the circle multiple times. You notice that sometimes I went backwards, sometimes I went forwards, etc. So there's going to be multiple ways that I can write polar coordinates. So I'm given one polar coordinate right here, 3, pi over 6. So this is r, remember, and this is theta. So r is how many steps you're taking, and pi over 6 is your angle. All right, so it tells me to write it 3 other different ways. Okay, so the first way is r is still positive. Okay, so basically I already have a positive r, so r is not changing. I'm still taking 3 steps forward, but this time I want theta between 2 pi and 4 pi. Okay, so all that's saying is I want to go another lap around my circle, because I know that I can go 2 pi, a full circle is 2 pi, and so therefore if I go another time around my circle, it should end me up at the same angle. Alright, so letter A. My r value is still 3, and then I know pi over 6 plus 2 pi will get me the same angle. Okay, so pi over 6 plus 2 pi, okay, gives me 13 pi over 6. Alright, so that's going to be another way that you can write this angle. All I did was add 2 pi because we know that another lap, it goes back to coterminal angles. Pi over 6 and 13 pi over 6 are coterminal angles. Okay, so we should be okay hopefully with that. Alright, so same thing for part B. Okay, so in part B, it says r is less than 0, okay, and theta is between 0 and 2 pi, okay? So here we have to look at, okay, pi over 6 is right here, and I want to go 3 steps forward, okay? Well, I want to look at what is the angle on the opposite side, okay, that I know r has to be negative, so -3. What angle over here could I face? So I'm facing this angle over here and walk 3 steps backward. Because remember, my goal is to get over here. So my question is, I'm facing this direction. It's telling me r has to be negative, okay? So, but I need to walk 3 steps backwards. So if you remember, this angle on your unit circle is going to be 7 pi over 6. So what this is saying is when you face 7 pi over 6 and walk 3 steps backwards, you will get to the same spot on your unit circle. All right, last one is part C. Okay, and part C also goes back to coterminal angles. Okay, it says r is positive, so we're going to go back to a +3. Okay, but this time it says it's between -2 pi and 0. So if you remember, we can, in degrees, we can add 360 or we can subtract 360. In radians, we can add 2 pi or we can subtract 2 pi. Okay, so instead of adding 2 pi, like I did to get 13 pi over 6, I'm going to subtract 2 pi. And I'm going to go ahead and simplify that with a common denominator. So I get -11 pi over 6. And I think we actually did an example like that. Yes, that was like letter E when we plotted those coordinates. Okay, so -11 pi over 6 is the same angle as +pi over 6. Okay, so A and C hopefully are not too bad. They're just thinking about coterminal angles. B is the one where you have to kind of think, what is the angle across from it that I can walk backwards and get to the same spot? So that's the one that's a little bit trickier. Okay? All right. So now we're going to talk about converting from polar coordinates to rectangular coordinates. So these are polar coordinates, but we're going to talk about, well, what if I wanted to take those and turn them into rectangular coordinates? Okay? So rectangular coordinates being what you're used to is x, y, okay? So you will need to know these two formulas right here. You will need to pretty much have them memorized, and when I say that, they'll become pretty much common knowledge once you start using them, okay? And you should remember from your unit circle, you have x, y, and you have cosine, comma, sine, okay? So again, this is the x goes with the cosine, the y goes with the sine, okay? All right, so we have some polar coordinates here, and I want to find the rectangular coordinates. So all I'm going to do is I'm going to use those formulas to do it, okay? So x equals r cosine theta, and y equals r sine of theta. So all I did was plug in those values. Okay, now we're not done yet. We actually have to find out what those are. So let's go to pi over 6 on my unit circle. The coordinate there is square root of 3 over 2 and 1/2. All right, we can plug this in. So x equals 6 times square root of 3 over 2, because that's my cosine value. All right, and I'm going to simplify this. So 6 divided by 2 is 3. So I'm left with 3 square root 3. And then y, we have 6 times 1/2, and that's 3. So my x, y coordinates, or my rectangular coordinates, are 3 square root 3, comma 3. Okay. We're going to do the same thing in part B. okay? So x equals r cosine theta, and y equals r sine of theta, okay? Now do make sure this is negative pi over 4, so that's going to be down in my fourth quadrant at 7 pi over 4. So the x value is square root of 2 over 2, and the y value is negative square root of 2 over 2. So I have x equals negative 4 times square root of 2 over 2, and y equals negative 4 times negative square root of 2 over 2. When we simplify all of that, we're going to have some cancellation. The x will end up being negative 2 square root 2, and the y's, a negative times a negative, will end up giving me a positive there. Okay? Alright, the last thing we're going to do is we're going to go backwards. So what if I gave you the rectangular coordinates and I want you to find the polar coordinates? Okay. So again, if I gave you the xy coordinates, we want to find what is that angle and how many steps, or what is my radius that I took to get there. Okay. So there's a formula to do this. The radius equals square root of x squared plus y squared. This comes from Pythagorean theorem. Okay, so if you think about it, I'm not going to go through the whole proof right now, but think about it. A squared plus b squared, that's x squared plus y squared, equals r squared. That's your hypotenuse. Okay, and then you would take the square root of that. That's essentially what you're doing right there. So if you get lost, you're really just making a right triangle, and you're using Pythagorean theorem. I'll write that down. Okay, now how do you find theta? Well, we know this is y and this is x. Okay, well, we know theta is opposite, or we know the easiest way to find it, because we don't know if r is the whole number or not. The easiest way to do this would be opposite over adjacent. Okay, so y over x, and opposite over adjacent corresponds to tangent. Okay, we know when we're trying to find an angle that we're going to have to use tangent inverse in our calculator. Okay, and this kind of goes through, again, this right here, just Pythagorean theorem. Okay, and if you want to find r by itself, you would just take the square root of both sides. Alright, so find the polar coordinates of a point whose rectangular coordinates are 0, 3. So we're up here at 0, 3. Just going to go ahead and sketch that real quick. So we know r squared equals 0 squared plus 3 squared. So r squared equals 3 squared, r squared equals 9, r equals 3. Or remember, it could be negative 3, because when I take the square root, I have to account for the positive or negative. And remember that our r value, like we talked about on the previous page, actually it was 2 pages ago, but I can take 3 steps forward, or I can look the other direction and take 3 steps backwards. Okay? Alright, so let's talk about, if this one's probably easy to visualize because it's exactly on one of our axes. Okay, so we don't even really have to do the tangent. So if it's 3, I can think about, well, what angle is right there at 0, 3? Well, we know the angle at the top is pi over 2. Okay, well, then I have to think about, if I were to face the other direction, okay, and again, the other ones will have to do tangent, but this one's a little bit more intuitive. Okay, if I were to face the opposite direction, okay, and want to take steps backwards, what angle is directly across from it? Okay, and the answer to that is 3 pi over 2. Now, if it doesn't give you any restrictions for theta, you could write 3 pi over 2, or you could write negative pi over 2, it doesn't matter. If it told you, like, it had to be between 0 and 2 pi, obviously you would have to write 3 pi over 2, okay? So, but for this one, it doesn't give me any restrictions, so it doesn't matter whether you write that as 3 pi over 2 or negative pi over 2, because those are the same angle, like we talked about a couple pages ago, all right? And those would be your final answer. Okay, so whenever you're asked to find polar coordinates, you need to find both a positive r value and a negative r value. Obviously, you don't have to keep going and adding 2 pi and finding, because there are technically infinite solutions, but you need to find one with a positive and one with a negative. Okay? All right, so find polar coordinates, and then it gives us the two rectangles. So the first thing I'm going to do is find the r value. So r squared equals 2 squared plus negative 2 squared. So 4 plus 4, r squared equals 8. When I take the square root of both sides, so plus or minus 2 square root 2. Alright, I'm also going to go ahead and plot that point. So 2, negative 2 is going to be in my fourth quadrant. And I'll tell you why I'm going to do that in a second. Alright, so I'm going to have two answers we know. So my first r value is 2 square root 2. My second is a negative 2 square root 2. Okay, so the next step in order to find the angle, okay, again, you might not know exactly what angle that is, so we're going to practice finding the tangent. So tangent inverse of y over x, so negative 2 over 2. Alright, so we're going to make sure our calculator is in radian mode. Okay, so tangent inverse of negative 2 over 2. And so we're basically asking, where does tangent equal negative 1? And actually I would probably do that without your calculator, because then you have to deal with converting with pi. Okay, so that angle right there, when tangent equals negative 1, we should know that that angle is 7 pi over 4. Okay, so because we're in the fourth quadrant, okay, and that's why I drew my picture, is because this point, 2, negative 2, is in the fourth quadrant down here at 7 pi over 4. So that tells me that 7 pi over 4 is the actual angle that I'm looking for. It goes with the positive r value, okay? 2, negative 2, that's the actual angle I'm looking for. That goes with the positive r value. Now the angle across from it, which is up here at 3 pi over 4, that's going to be when I'm facing the opposite direction and walking backwards, okay? So that would be in quadrant number 2, okay? But that's not the actual angle that I want, 3 pi over 4, but when you're facing there and walking backwards, that will give you what you want, okay? So just be careful. That's why I go ahead and sketch that out, because that tells you, okay, I want the 7 pi over 4 to go with my positive r value. All right, last one. So we have negative 1, negative square root 3. So somewhere down here in the third quadrant, okay? Actually, it should be down here, but anywho. All right, so negative 1, negative square root 3. So that tells me, again, it's in my third quadrant, okay? So r squared equals negative 1 squared plus negative square root 3 squared. So 1 plus 3. So r squared equals 4. So r can equal 2 or negative 2. Okay. So now I have to find out what is my angle. Okay, so I'm going to do tangent inverse of y over x. So the negatives will cancel out. So we're asking ourselves, where does tangent equal square root of 3? And the answer to that question is at 4 pi over 3. Okay, so 4 pi over 3 is down here. So that's going to go with my positive angle, and again, that helps when you know which quadrant you're in the third quadrant. Okay, and then the last thing we have to do is figure out what angle, whoa, it helps if you draw a straight line, is directly across from it if I drew a straight line. So I know if I'm facing the angle across from it, if I'm standing at the pole in the middle, pole is just how we refer to the origin in polar coordinates, okay? And I were to walk backwards too, I would end up at the same spot. So this up here is pi over 3. Okay? And that is how you convert from rectangular coordinates into polar coordinates. Okay? Next time we'll start talking about converting equations from rectangular to polar and polar to rectangular. Okay? And that's it for today.